worksheet. I want to make sure we've done them all because my expectation of you is that between now and Tuesday, you look at this thing again. So I want to make sure that we've worked them all out. So exponent worksheet, the front one. Tell me what we still need to do. Have we finished the whole front? We're on 23. This is what I want to do. I want to finish it. All right, so is everybody good? We're starting on 23. Marley, I shouldn't hear talking. All right, this is number 23, easy one. What does this mean? On our exponent worksheet, number 23. It means the cube root of 1,000. No calculator. You need to know the cube root of 1,000 is 10. 24. 1,000 to the negative first.
Just 1,000.
1 over 1,000 to the first. So just 1 over 1,000. Remember, negative exponents mean you flip. So 1,000 becomes 1 over 1,000. Here's another one of those kind of tricky ones. Don't fall for it. These are two separate numbers. This is 3. What's this one?
1 over 4.
Not 1 over 4. 1 over 4 squared.
1 over 16.
Which is 1 over 16, so our answer is
316.
316. 26 is exactly the same, but in a different order. They are separate numbers. What's 3 to the negative second?
1/3 squared.
1 over 3 squared, which is 1/9, times 6 over 1.
That reduces.
That's 6/9, which happens to reduce to 2/3. And then the last one, this is a good one because we have some issues with the practice one. This is our problem. Now, this kind of problem, there's a lot to be done. And the order that you do it doesn't matter. Okay? So, Quincy, what do you want to do first?
Because there's a negative outside, do you flip everything?
You can flip everything.
Look at that.
Now, listen, because this can be tricky. He said that negative flips this fraction. That means if it's on the bottom, it goes to the top. No changes. You are flipping the entire fraction. So whatever was on the bottom is now on the top, and whatever was on the top is now on the bottom. The negative has been taken care of. Okay, now what else needs to be done? What else could we do?
No, you put the X at the bottom.
Okay, so Kashani says, look, I got an X here, and I'm going to bring that down. And when I bring that down, that will give me a total of 7 of them down there.
7.
Now, while I'm at it, what about these 2 Y's?
1 Y at the top.
1 Y on the top. Why is there 1 Y on the top? Because there were 2 over 1, so that leaves me with 1 when I cancel. Right? Now what? Square everything, and when I square everything, I'll have 9y squared over 4 x to the 14.
About 10.
And there's the answer to the question.
We're doing the back as well.
Not today. Well, the back is just the answers, but there is another sheet.
Oh, fair.
We're not doing it today. Today, we are doing something super exciting. Get out your note sheets.
Yes.
Oh, yeah.
Yes.
Look at page 26.
This stats hard. Class.
Oh, sometimes it can be. It's interesting.
Well, I don't know. I think we were like when we're talking about the stats class.
50 cents.
Have to be AP?
Well, here it does, yeah. Okay, everybody got page 26 up? Oh my goodness gracious. What do we notice about this whole page? Logarithms. So today we are going to get exposed to basic logarithmic properties. Okay? This, believe it or not, is a no calculator page. You are going to be able to do this entire page without a calculator. So let me show you one of the properties. Problem number 1. Now pay attention. On problem number 1, you have the log base 5 of 5. Whenever you have the base of your logarithm and your number, the same number back to back, they actually cancel. This is 5 to the first. When I cancel these 5s, this all cancels and the answer is just 1. Now look at the second one. It's the log base 4 of 4 squared. I want to match these numbers. So instead of having a 16 here, I'm going to write 16 as 4 squared. Because as soon as these numbers match, they're back to back, they cancel, and the answer is 2.
Wait, why would it be?
Why would it be what? We don't do anything. This is a property. The property says the log base b of b to the n is n every time.
Oh, okay.
Every time.
1 every time.
No, it's not 1 every time. This time it was 2. Now I want to look at number 3 because it involves a notation that you're probably not, or maybe you are familiar with. Anybody remember what ln means? Well, it's called a natural log, and it is the symbol for log base e. So when you see an ln, you can leave it as an ln, or you can write it as log base e. So problem number 3 is the log base e of e cubed.
Which one's less confusing?
Well, in this case, I like to use the log base e, because what happens when we have 2 e's back to back like that? What happens?
They equal 1?
It cancels, no, and it equals 3.
Trey.
This one equaled 1 because that's what we had, 5 to the first. Here we had 4 squared, so it was 2. Here we have e cubed, so it is 3.
Oh, because they canceled.
Anytime you have the base and the 2 bases there, the base of the logarithm and the base of the exponent, anytime they are back to back, they're going to cancel. That is a property. This is a property of logarithms. Now, what about LOG? Does anybody know what LOG stands for? Well, what's the base on that? No, ln has a base of e. What's log have a base of, you know? It's base 10. Those are called common logarithms. Common logarithms. So every time you see log with no base, think of it as base 10. So problem number 4 is the log base 10 of 1,000. Now, you cannot cancel these. They do not match. But what do you know about 1,000?
It's the third root.
It's 10 to the... 10 to the second is 100.
Trey.
10 to the third. So this is the log base 10 of 10 to the third. And what's the log base 10 of 10 to the third? 3.
So whatever number is left.
Yep.
It's always
Yep.
gonna be the exponent.
It is. It's always going to be the exponent.
Ooh,
Yep.
I know.
It's always, this is the property. This is the property, so it's always going to be the exponent. What? Okay. Now, I want to skip down to number 9 because I want to do all the ones that are kind of easier first till we get warmed up to it. So skip down to number 9. You cannot cancel these because they don't match. But what do we know about 49?
7 squared.
7 squared. So we're going to write it as the log base 7 of 7 squared. So the answer will be 2. Are you starting to get the hang of it?
Yes.
All right, let's look at number 12.
What about all these ones in between?
We're going to come back and do them. Just hang loose there.
Sorry.
Number 12. Marley?
2. Never mind. Wait, if there's not a number after log, is it 10?
Yes, always. LOG, the symbol LOG means base 10. Always.
Also, is natural log like a logarithm?
Natural log is a symbol for log base E.
Okay.
Why don't they just write it the same time?
What do I do for the other
Our
side
job
at
is to
all?
make your life miserable. We're doing a good job, aren't we? The log of 100. Okay, remember, no calculator, so you gotta be able to figure this out. First of all, the base on that is 10. LOG is always base 10. These do not cancel until you make them the same. So log base 10 of
2.
10 squared is 2. Maddie?
I was supposed to leave it 2:35.
Oh, well then you better go. How about 13? What do you think? Anybody have an idea?
1.
1. Because in 13, we have,
Even though it's a log base 10.
13 is a log base 6 of 6 to the first.
But if it doesn't have anything, it's a log base 10?
Yes. Yes. Those cancel and the answer is 1. How about 15?
10.
That's 10. Remember, that's log base E of E to the 10. Those are going to cancel and the answer is 10. Let's see if there's any other easy ones. No, okay. So now we're going to go back and start filling in some of the ones that are a little bit trickier. Take a look at problems 18 and 19. They look different, don't they?
Yep.
They look different. But you see how in 18, you see how there's a 6 and a 6 that match?
Yes.
You want to take a wild guess what the answer is to 18? 10. Yeah, they cancel. What do you think the answer to 19 is?
2.
2.
Is there ever a time where they don't match?
Well, there could be, but that would be a hard problem that I'm not going to give you.
And we would just say no.
You would just say, well, you would say you'd have to do some other work to figure it out. All right. What about 22? Now, you're freaking out when you see that, but what does LN stand for? So E to the log base E of 4. What does that equal? 4. Yep. So number 22 is just 4. What about 23? 11. How about 24? 7. Uh-oh, 25 looks different.
I would do 7.
Remember,
It's 7.
what's the symbol for LOG? What does that stand for? Base 10, right? So number 25, the answer would just be 7. How about 27?
6.
6.
E to the log base E of 6. Remember, ln is log base E. So if you're confused, write it as log base E. Okay, those are pretty easy. Now we're going to look at the harder ones. So are we ready? Number 5, our first one?
Yep.
Yes.
Okay,
Oh, I.
so we have the log base 4 of 1/16. Now, in order to do this, we need that to be a 4. Okay, so let's see. How are we going to make that a 4? Okay, so we have the log base 4 of 1 over 4 squared. It's 1 over 16.
Oh, no, -2.
Multiply by
Ah, it's
-2.
-2, somebody over here said it. That is the log base 4 of 4 to the -2nd. Remember, when you flip something and make it 1/4, didn't it used to have a negative exponent?
Yeah.
So we're just going backwards? So what's the answer to problem 5?
-2.
-2. -2. Try to stay up with this. We're gonna practice some more. But try to stay up with it. So ln 1/e cubed. Stop. Oh my gosh, there's so much going on here. Log base e of 1/e cubed.
Log base e.
Cancel the e's.
To the negative
Can't
third.
cancel the e's.
Put it.
When it's 1/, you can't, but you can flip it over and make it log base e of e to the -3rd.
Yes.
What number is it?
This is number 6. And the answer then would be -3. You really need to understand your exponents in order to do this. All right, number 7. Anybody take a wild guess?
Which one? Number 7.
Number
I
7?
think it'd be
1/3. Bingo! Because when I have a cube root is the same as 1/3 power. And in order to do this, I have to have these two numbers back to back. I can't have a radical in the way. I have to have them right next to each other. So I'm going to rewrite that radical as a 1/3 power because cube roots are 1/3. And the answer to the problem then is 1/3. Number 8 is just plain hard. Can anybody figure it out? It's hard.
I
Marlon?
have a question about the last one. Would the answer also be -3?
No, because -3, 6 to the -3rd would be 1/6 cubed. Radicals are not negative exponents. Radicals are fractional exponents. Okay, if it were 1/6, I would be doing a negative exponent, but it's not. This is a hard one, really hard. Anybody have a thought on that?
1/4.
No, that's a good guess. No,
0.
it's 0. Yeah, it's 0. And it's 0 because what's 4 to the 0th power?
All 1.
1. So we have to think of 1 as 4 to the 0. So the answer is 0. Number 10, we're going to do just a couple more, because I know this is a lot of information for one day. Number 10, what do we have in number 10? We have the log base 10 of 1/10. You can't do it until this is a 10. So what power would that be if it's a 1/10? -1. So what's the answer to the problem? -1. You gotta figure out the power, and that's the answer to the question. Okay, log base 3 of 1/9. Gotta figure out the power.
3 to the -2nd.
Very good, Marley. It's 3 to the -2nd. Now, for those of you that are in weekend mode already, you gotta stop and think about a couple of things. First of all, 9 is 3 squared. And since it's 1/, that makes it 3 to the -squared.
Yeah.
So the answer to the problem is -2. Number 11 is -2. Try 14 by yourself for a minute. See if you can get the answer to 14.
1.
We already did this.
I don't think we did
We
14.
did not do it. Nope.
The answer is 1/2. And the answer is 1/2 because, first of all, these are not back to back. There's a radical in the way. What power does a square root stand for? 1/2. So instead of a square root, let's write that as 7 to the 1/2. And now the 7s are back to back, so the answer is just 1/2. So the answer to number 14 is 1/2. All right, well, we're almost done. We might as well finish it, huh?
Yeah.
What's, where are we headed for, 16? 16 is 1/3. Because when you see a cube root, it means 1/3 power. So 16 is 1/3. What about 17? -1. Because what does 1 over e mean? E to the -1st. Very good. Uh-oh. 20 is hard. We've got that extra number sticking out there. Let's look at 20. Let's pretend that 2 weren't there. Let's pretend that wasn't there.
That would be 2. The answer
This would be 2. Very good. You're getting the hang. That's really good because 9 is 3 squared.
is 4.
So this would just be 2, right? That's 2. What are we doing with this guy out here?
Multiplying
Multiplying it. So the answer will be 2 times 2 or 4. All right, 21 is the same thing.
9.
We have the log base 2 of 8, and it happens to be times 3, but we're going to wait on that. You can't do this until these match. So what's 8? 2 to the third. So the answer to this much of it is 3. And what are we doing with that 3? We are timesing it by 3, so the answer is 9. All the way down. What do you think about 26?
4.
It's 4. Because what's the log base 2 of 2 to the first? That's 1. There's a 4 out in front, so the answer is 4. And finally, number 28. 0. Anytime there's a 1 there, the answer is going to be 0 because you're rewriting that as the log base 8 of 8 to the 0. Now, I am looking at the very next set of my note sheets, and it says evaluate with calculator. So you might want to have a calculator with you next time. All right, Christian, give me my thing.